Okay, everybody, so last video we learned about angles of rotation and how we draw angles in standard position. So when we draw angles in standard position, remember the initial side always lands in the positive x-axis, the vertex is always at the origin, and then if you have a positive angle, you move up from the axis, and if you have a negative angle, you move down from the axis until your terminal side lands in the right spot. Also remember, you always have to draw your angle-like marker to indicate which way you went and how far around you went. So now we need to talk about something called a reference angle. So both angles in standard position and reference angles are going to be super important for what we're going to be doing moving forward. So it's important that you understand these concepts. So a reference angle, I'll give you a verbal definition first, is the angle, oops, it'd be nice if I could actually write what I say. The angle between the terminal side and the nearest x-axis. Now I emphasize x because it's all about the nearest x-axis, so nearest horizontal axis. So I'm going to draw a few examples so you can see what reference angles look like. So let's draw 3 angles in standard position, and we're going to find their reference angles. So the first one I'll draw will be 150 degrees. The second one I draw will be, let's make it negative 215 degrees. Actually, let's make that -1/3, negative 115. And then let's do a 500-degree angle. All right. And by the way, when you draw your little angle measures, you might want to put arrows on them to indicate which way we went. Okay, so reference angle. What we're going to do reference angles, let me get a color I haven't used yet, purple, is we're going to go to the terminal side, which is here, and we're going to choose the nearest x-axis, which in this case would be this measure. And the reference angle is this angle right here. Now, if you look at this whole angle with this particular instance, my original angle, the 150, and my reference angle together make a 180-degree angle. So my reference angle in this case, because my original angle was 150, is going to be a 30-degree angle. So let's look at the second, the negative 115. So again, I go with the terminal side. I go with the nearest x-axis. This is my reference angle. And then again, if you look at these two angles together, they make a straight line angle, the 115. By the way, I'm taking the negative off of it because that just indicates a direction, right? So the 115 and the reference angle together make 180 degrees. So my reference angle here is going to be 180 minus 115, which is 65. Now, you may look at that and go, but we're moving in a negative direction. Shouldn't that be negative 65? You could make an argument for that. However, conventionally, let's write this in our notes, the measure of a reference angle must always fall between 0 and 90 degrees. Which means we want it to be a positive number. And you're going to see why when we start using the reference angles a little bit later on. So really, reference angles are the angle between the terminal side and the nearest x-axis, regardless of direction you move to get there. Now, reference angle can't be bigger than 90 because if I were to draw an angle that is a 90-degree angle, right? Its reference angle, the nearest x-axis, we could either go to the positive x-axis or the negative x-axis for our reference angle, and it wouldn't matter. Those would both be 90, right? Now, if my angle had been like 89, my nearest x-axis is now clearly the positive one. So it can't be bigger than 90 because as soon as you cross over a y-axis, you're using a different part of the x-axis for your reference angle. So let's look at that 500 degree. Here's the terminal side. Here is the nearest x-axis. This is my reference angle. Now, we have to do a little more thinking here in order to get the reference angle here, because we know the angle is 500 degrees, and we know that the initial side of the angle and the terminal side of the reference angle, again, make a straight angle. It's 180 degrees. So if I'm looking at this, I need to figure out what angle is coterminal with this 500 degree angle. And remember, coterminals share terminal sides. So I went around a full rotation, 360, and then I went around more to make the 500 degree angle, right? So if I think about the 360 being part of the angle, that's the 360, and then the rest of the angle is going to finish up that 500, right? So if I take 500 and take away 360, that's going to give me 140 degrees. So 140 degrees and 500 degrees are coterminal. They share a terminal side. In fact, coterminal angles are always separated by multiples of 360 degrees. Because that's going around a complete circle, right? You land in the same spot. So if you add 360 or add 720 or add 1080 or subtract 360 or subtract 720 or subtract 1080 from an angle measure, the angle you get is going to be coterminal. So now that I know this 140, I could have simply said 500 minus 360 gives me 140, and that will be a coterminal angle. So now I can look at the 140 along with the reference angle and know that the reference angle's measure in this case is 40 degrees because the 140 and the 40 together make 180. So the important concepts from this particular video. The reference angle is the angle between a terminal side and the nearest x-axis, regardless of direction. Your reference angle has to be somewhere between 0 and 90 degrees, can't be negative, can't be bigger than 90. And sometimes you have to get a coterminal angle in order to be able to get a reference angle. And to get the coterminal angles, you add or subtract multiples of 360.